Hi, I'm Seda. Uh, for us, the most priority purpose in the Global Sustainable Development Plan is the struggle against climate change. Before the other general problems of the world, the healthy and livable planet comes. That's why we choose this subject of our homework. Uh, if we talk about the methodologies we use, in this research, we examine various sub-branches on climate change. Among the climate change problems we are working on there are subjects such as ocean temperature anomaly, the effect of global warming on land temperature, the percentage of forest areas according to years, the amount of melting of glaciers according to years, the change in sea level according to years. We use many Python libraries to process and visualize this topic in detail. The first technique we use, the linear regression technique, is in the subcategory of the supervised group. This technique is used to predict the value of one variable based on the value of another variable. We have seen that the query of this technique can be high because the data in the dataset we use this technique follow a more linear paths. Therefore, we taught the algorithm to predict by creating test and train test, and we got a prediction result with high query. In other words, we have proven that the linear regression technique is suitable for this dataset. The other technique we use is the K-means algorithm, which is the algorithm of the clustering method, which is a subcategory of the unsupervised group. K represents the number of clusters. It has K center points. According to these central points, if clusters are formed and continue until the system is stable, the reason for using the clustering technique is that the data in the dataset we use is not in a certain linear plane, and data groups are formed in the form of clustering. In this study, we used the forest land dataset to show the 30-year change in forest land by country. With yet another dataset, we analyzed glacier area data by year, month, day, and hemisphere. The dataset, which includes ocean temperature anomaly data between 1880 and 2021, is also among the questions we examined.
Hello everyone, my name is Baran Datlar. The primary inference that the K-means algorithm is used to make from a dataset is the identification of natural clusters or groupings in the data. By partitioning the data into a specified number of clusters, the K-means algorithm allows you to discover patterns and relationships in the data that might not be immediately apparent. We use the K-means algorithm on two different datasets. Both show anomaly values for ocean and land. We use the same algorithm as both groups of data had similar features. The reason we use the K-means algorithm is that we want the group according to the anomaly values. As the years progressed, we can understand from the graphs that the clustering shifted towards positive anomaly. Thanks to this grouping, we can clearly observe the relationship between years and anomaly values. This area shows libraries. We pulled the data of the subject that I will explain in this section from the globalwarming.org API. Here is the API comments, and here is the R function. The do K-means function takes in a data frame and the optional number of clusters. It uses the K-means model from sklearn to fit data, predict the cluster labels for each data point, and calculate the cluster centers. The cluster labels and centers are returned as a tuple. Here is the graphics. The graph above is the area chart with grid graph showing the 40-year change graph of the data we use. The graphic below is a visualization of the K-means algorithm that I just described. In this part where we describe the ocean anomaly, we used a CSV file as a dataset. The algorithm we use is the same as the land temperature anomaly I just mentioned. The reason for this is that the data is very similar and it's suitable for the K-means algorithm I just mentioned. The graph above is a bar chart showing a 40-year change graph of the data we use. The graphic below is a visualization of the K-means algorithm that I just described.
Hello, I'm Giray Çelikkaya. This is the first dataset that I will mention. I simplified the dataset by using for loop in this part. In this part, I visualized the dataset by using scatter pilot. And in this part, I used linear regression machine learning technique for predict the data. In this graphic, I choose the world forest area percentage, and this is the linear regression line. This is the second data set that I will mention you. In this part, by using for loops, I simplified the data set. This is the part of graphic visualization I used. Uh, this is glacier mean extent by year data set. In this part, I simplified data set by using for loops. This is the graphic visualization part. I choose line chart for visualization. This is the part of machine learning technique. I used linear regression. I split the data to train and test set, and I choose the test set size 0.4. This is the first graph that shows the glacier mean extent by year from 1980s to 2020. This is the second graphic that shows predict line.
And to bend in this section, I will describe the part where we analyze and visualize a data set called sea level, which includes time, GMSL, and GMSL uncertainty data. The GMSL value means the global mean sea level, and the GMSL uncertainty explains the difference in error and sensitivity. That is uncertainty that can be made during these measurements. The reason for this margin of error that the shape of the ocean bottom isn't constant and changes through the world. And the first graphic I want to explain is this. This code reads a data set and plots it using the GMSL. GMSL means global mean sea level, and the GMSL uncertainty, this means global mean sea level uncertainty data in it. First, this CSV file read and the date data is inserted as a column named time. It is then cycled from 1880 to 2030, and the average GMSL and the average GMSL uncertainty are calculated for each year. This data is appended to a data frame named time, GMSL, and GMSL uncertainty. Finally, two line graphs are done and displayed in green using the GMSL value, and the red one is using the GMSL uncertainty value. You can see in this graphic. And the second graphic I want to explain is this. In the second graph, we predict how the GMSL value will change in the process from 2013 to 2050 with the linear regression method. Our conclusion is that the height of sea level will increase over the time. And to put in a nutshell, I want to explain conclusion part. As a result of our research and the data visualizations, we can conclude that the climate crisis seriously threatens our world. The extent of the melting glaciers and the rise of sea level, the decrease of forest surface area, the anomaly of ocean and land temperatures were examined between 1880 and 2020, and predictions for the future were made. The images we have produced as a result of these predictions reveal that the problem will continue rapidly in the future. Thanks for listening.